Now, in order to create a much better filter that has less artifacts, we have to create a Gaussian filter instead of an ideal filter. For that, we have to write the same Gaussian function that we had in the frequency domain side, and only this time we do not need to multiply the end result of the Gaussian, as the amplitude does not matter this time, but the overall area under the Gaussian is the one that matters. And again, the size of the filter is what determines how the audio is filtered. Here you can see the shape of the filter itself and how it's been applied to the audio source. Additionally, what we can do is we can take the data that we have gotten from the time domain convolutional filter, and we can compare it with our results that we got from our frequency domain filter. For that, we have to convert our time domain data that has been already filtered into frequency domain, just like we did last time, and I'll also add a frequency domain filter here just to compare the two. For the case of the frequency domain filter, I will just apply a simple ideal filter instead of the Gaussian.